Okay, today guys we're going to talk about parabolas, and I know that you've learned about parabolas in the past, but today we're going to talk about some things that you may not have thought about before. The first is, what is a parabola? Well, we've learned it as being produced by an equation that has an x squared, but let's talk specifically about the graph a little bit more. First of all parabolas have a focus point, which I'm going to call F right here. It's called a focus. And you have a directrix, which would be a line over here. And imagine that that is horizontal. That, again, is called the directrix. And a parabola, by definition, is all of the points that are the same distance from F as they are from D, the directrix. So in other words, if I pick this point right here, the vertex, it's the easiest one to pick, this distance here is the same as this distance here. But I could pick any point on the circle. If I came up here and picked this point, any point x, y, we call the point P, is the same distance to the focus as it is to the directrix. So this distance here is the same as this distance here. Now, I am human and I cannot draw very well, so they don't look the same, but if I could draw perfectly, they would be the same. So that's what a focus and a directrix are. The other thing that we're going to be talking about today is the line of symmetry. And let me pull out a shape for that one. The line of symmetry would be where you could fold the parabola on top of itself and it would line up perfectly. And so if I inserted a line here that could go through that focus point and that vertex, that would be my axis of symmetry. So let's write that one down. Axis of symmetry. Alright, so three things. Focus is the point, directrix is the line behind the parabola, and then the axis of symmetry is where you could fold the parabola on top of itself. Okay, I want you to write down that statement that I made a minute ago so that you'll remember to review it, that the distance from the focus to any point equals the distance from the directrix to that point. So again, that's really important. Take a moment to write that down. Okay, our first example is going to be one of the more complicated examples to think about, so please pay attention. This asks us to write an equation for all the points equidistant from this focus and the line y equals -3, which ends up being our directrix. And so I want to start out by visualizing what is going on. So I've got a parabola whose focus is at 0, 3, and the directrix is at y equals -3. And so if you pick any point x, y on this graph, then again, this distance here has to equal this distance here. So what else do we know? If this point that it touches on the line of the directrix, what do you know? Well, the y value has to be -3. So that point has some x value, -3. Not only is it just any x value, it's the same x value as this point that's directly above it that we're trying to make our distances match with. So we can just call it x because it's directly under this one, which we're just calling x, and we know those have to be the same number. Alright, now we know these two distances have to be equal, so we're going to use the distance formula. The first one I'm going to do is this distance between 0, 3 and xy. So I'm going to do the square root of 0 minus x squared plus 3 minus y squared using my distance formula. That's going to have to equal the distance between these 2 points. So, again, square root this point minus this point. So, x minus x squared plus y minus negative 3 squared. And then I should be able to work this out somehow after that. Well, 0 minus x would be negative x, and square that would be positive x squared. So I have x squared. And then 3 minus y, I'm going to have to write out twice and FOIL, or double distribute. On the other side, x minus x is 0, and so 0 squared is still 0, so this part really goes away. This becomes y plus 3, and again, it's squared, so I'm going to have to write it out twice. Y plus 3, y plus 3. The other thing that happens is these are both square rooted, so if I just square both sides, I can cancel out these square roots. And I'm back to working with something that works. So x squared plus double distribute or FOIL, you get 9 minus 6y plus y squared. On the other side, you get y squared plus 6y plus 9. And I'm going to move my y's to this side to try to get things combined. So I'm going to subtract y squared. And they're going to go away in both cases. I'm going to subtract 6y. So I'm going to have to combine those. And I'm going to subtract 9. And those will go away because you have positive and negative. So on this side, everything goes away to 0. And over here, I have x squared minus 12y. Well, that is like a parabola form because I have an x squared in it and a y. So I can solve that and make it look like the equation for a parabola just by getting the y by itself. So if I subtract x squared, I have negative 12y equals negative x squared. Divide by negative 12, and I'm going to write it as a fraction. The two negatives will make a positive. So I'm going to have 1/12 x squared. And so there's my equation of a parabola that meets these conditions. Okay, before we move to the next problem, I want to talk to you about this formula. You actually get this formula on your formula sheet for the state exam, and this is the absolute value of A equal to 1/4C. So you're like, what are A and C, and why do they have any meaning? C is the distance from the vertex to the focus or from the vertex to the directrix, since those are the same. And A is the number that is in front of X or Y. And notice we have the absolute value of A because, you know, sometimes that number is negative. One of the things that you have to remember is what does a negative do to a graph? And when we were working in our toolbox functions, you knew that the graph of y equals x squared was a parabola that faced up. And if I put a negative in front of that and did y equals negative x squared, that would be a parabola that faced down. We are now going to move into things that aren't necessarily functions, meaning they don't necessarily pass the vertical line test. So we're going to look at x equals y squared, which would be a parabola that opened up to the right, and x equals negative y squared, which would be a parabola that opened up to the left. And these four things, you probably already know these two, but at least these two you need to take the time to put it in your memory and recognize what's going on when you have these graphs or these equations.